Hi guys, and welcome to the weeks 14 through 16 Start Here module. This is actually our final Start Here module of the semester. I've decided that I think it makes the most sense to combine weeks 14 through 16 together because the final exam is right around the corner. December 6th through December 13th is the window within which you could take the final exam at the testing center. The weeks 14 through 16 will be combined into one. Week 14 is essentially the last new week of content. Like I said in the last Start Here video, I've really kind of pushed hard to, make you work hard throughout the semester, and then week 14 is sort of the last new content week. Discussion board due Wednesday, homework due Sunday, quiz due Monday. These are the final assignments. And then weeks 15 and 16, you get to focus on studying and taking the final exam, So December 6th, you could technically take this final exam before final exams week, all the way through Wednesday of final exam week. So please plan accordingly for that. So this is the last homework and quiz. This week you'll be looking at a multivariable world, and so basically thinking about multivariable functions and how they apply in the real world, and rates of change in partial derivatives. Now also I'll point out that all of the material on the final exam is located in this week's module, so please see that information so that you know exactly what times and what days and all that, all the logistics of the final exam are posted in Canvas. Finally, I'll go ahead and wrap up the discussion board on the mysterious crash. And we have this plane that ended up crashing, and we want to kind of understand why. So we first of all wanted to kind of consider this worst case scenario of how tail versus front heavy could this plane be. Well, the worst case is that we have 50 people, and we'll just say 2 standard deviations, because that's pretty much 100% of people right there. I mean, 3 standard deviations is 99.9, but close enough. So worst case, 50 people will be 2 standard deviations below the mean, and 50 people will be 2 standard deviations above the mean. The first 50 people will be up front, and the second 50 people will be in the back of the plane, thus tail heavy. So you can't put all 100 people in the back or 100 people in the front, but you can kind of split the 2 halves and say one half is heavier than the other, assuming everybody's kind of equally spaced throughout the position of the plane. So what that means is that the people who are 2 standard deviations below the mean are about 112.6 pounds per person, since each standard deviation is 29.8 pounds, and the person who's 2 standard deviations below the mean will be 2 times that standard deviation below 172.2 pounds. So 112.6 pounds per person, that's the worst case. And then if all people were 2 standard deviations above, that would put it at 231.8 pounds per person. Now this is for 50 people up front and 50 people in the back, so 112.6 pounds per person times 50 people means that the front of the plane would have 5,760 pounds. But if all those, the heavier people were in the back at 50 people, that's 11,590 pounds, and that's 5,830 more pounds of weight in the back of the plane than in the front of the plane. So that's more than double the weight in the front, hence very tail heavy. So these things can, in theory, happen. They don't happen very often. This is the most extreme case, but we can see how wild this could possibly be if people randomly do seat themselves, and this is a random possibility that this may happen from time to time, and this is very similar to what happened in the actual plane. We now consider the baggage distributed throughout the cargo hold. In an ideal setting, a bag weight of 50 pounds, the maximum weight allowed would be an extreme for any given flight. In other words, people would probably bring bags that weigh well below the minimum, but that's up to what you're allowed to bring. Since, however, we are dealing with a normal distribution, we will at the very least assume that very few people have bags that have weights near the described maximum. That is, a bag weight of 50 pounds would likely be 3 standard deviations away from the mean. Suppose the bag weights are found to be normally distributed with a mean weight of 25 pounds. What would the standard deviation of bag weights be? Describe in words what the value means. Is it realistic, given what we know about bag weights? So we know that a standard deviation is for some value to be 3 standard deviations away from the mean, and the mean is 25 pounds. That means a bag weight of 50 pounds would be 25 pounds above the mean, and that means that if I were to solve for sigma, just like solving for x, I would see that bag weight would be 8.3 standard deviations away from the mean. So basically 0% of people would essentially have that bag weight. And that's using our idea of the z-score. In other words, what's the difference between the value and the mean, and then how many times does the standard deviation go into that difference? So that's a very, very extreme case. And of course, we know that some people do have 50-pound bag weights, or maybe potentially even more, so maybe this is not such a realistic value. So we could say that most bag weights will be between about 25 minus 3 times 8.3, so about 0 pounds and 50 pounds. So I'm sorry, that's what the standard deviation would have to be. So on average, bags would be 8.3 pounds below the mean and 8.3 pounds above the mean, but 3 standard deviations in either direction would basically say that all bags are between 0 pounds and 50 pounds, which is definitely true. So I'm sorry, that does make sense. For the second case, for a mean amount of 20 pounds, we would find that most bags would weigh between negative 10 pounds and 50 pounds. That, of course, is not a realistic value. However, even with that standard deviation, we would still be within the range of all possibilities. For a mean of 34 pounds, most bags would be between 18.1 pounds and 49.9 pounds, that's probably the most realistic case, because why would somebody bring a bag, let's face it, with a weight of 5 pounds? Probably doesn't happen very often. So that's basically it for this discussion board. The goal was to kind of get us to flex our reasoning about the normal distribution, use those concepts, apply them to a situation, and believe it or not, this kind of situation really calls for this type of simplicity where all we're doing is sort of understanding means and standard deviations in worst case scenarios. So the idea is random. We don't really ever know exactly what's going to happen, but we expect things to kind of happen within the norm, within a couple standard deviations of the mean. That doesn't mean that the worst cases cannot happen. So perhaps the recommendation for this airline would be to make sure that the weights are distributed better. However, now, I'm not familiar with the way the airline industry operates, but I imagine that nowadays they probably take a little bit more precaution. So that's it. Have a great week 14. I'll see you in the final discussion board, and we're almost there. So stay strong and let's keep fighting on until the very end. So see you in the discussion board and have a great week.